Hi everyone and welcome to the notes or the video for chapter 3.1. We're looking at area here. This is Mr. A. Now before we get going, what I suggest you do is you get your exercise book out and write down all of these formulas that we're going through. We're going to start simple with things from year 7 that you should remember from then, and we're going to get a little bit harder and harder as we go along. So please copy down the formulas, copy down the examples to have in your books. Here we go. First up, we have our rectangle. The area, or the formula to find area for a rectangle is equal to length times width. Again, you should remember that from year 7. Next up, circle. Area equals pi times the radius squared, and you can see what the radius is there in that little picture for you. Our sector. Now, a sector is actually a part of a circle, so it's not a full circle, it's just a certain part of it, a sector. The formula for the area of a sector is equal to theta, and you can see theta at the top of the sector there, that's the angle, divided by 360 times pi times the radius squared. And all of these numbers, theta and the radius, will be given to you in the question, or you'll have to work it out somehow, and we'll have a look at some examples as we go along. Next up, our triangle. Area for the triangle is equal to half times base times height. Next up, our trapezium. Before we go into the formula for a trapezium, you'll notice that a trapezium has two sides that are parallel, and you can see that there. That's indicated by the two arrows on the top and bottom lines of the trapezium. So those two lines are parallel, meaning that they'll never touch. You can see the formula, area equals a half, in brackets a plus b, times height, and again all of those numbers will be given to you in the question. All you have to do is know what formula to use, so it's not incredibly complicated. Next up, a parallelogram. Now a parallelogram, like you can see in the picture, all the lines are actually parallel to each other, so the top and bottom lines are parallel to each other, and the left and right lines are also parallel, hence the name parallelogram. The formula to find the area for a parallelogram is equal to base times height. That's all it is, very simple. Next up, we have our kite. A kite kind of looks like a diamond if you look at it closely. It's the shape of a diamond. The area for that is a half times x, which is the width of the base, times y, which is how tall it is. So again, these sorts of things you'll be given in the question, and you'll notice there that it's quite similar, or the formula is quite similar to finding the area of a rectangle. Remember, area of a rectangle is length times width, which in this case, if we use the letters here, it would be y times x, or x times y. Doesn't really matter, but we have that half in front there, which means that a kite turns out to be half the size of a rectangle, and you can see the missing corners in the sides there. Next up, our rhombus. Again, looks similar to a diamond, except all four sides are the same length. Now the picture that you see there isn't quite drawn to scale, but all four sides are the same length, compared to the kite where you have two sides are the same length, and then the next two sides underneath that are the same length but different numbers. So the rhombus, again, same formula there, area equals half times x times y. Now let's get into some questions that you'll be getting in chapter 3.1 and have a look at some examples. I won't actually work them out for you because they are quite simple, and you should be fine as long as you know what formula to use for what. So, chapter 3.1 is looking at composite shapes. That means that we have one big shape made up of smaller individual shapes. So you can see the example that I've given you there. But if we start to break that up into what shapes it's made of, hopefully you can see that it has a triangle, a rectangle, and half a circle. And I've broken them up for you there, and you can see the different lengths of the different sides. So all you have to do is find the area of all those three shapes and then add them together. So you find the area of your triangle, half times base times height, find the area of the rectangle, find the area of your half circle, and then add those three answers together, and you'll get your answer for the whole shape. Okay, so please have a go at those from 3.1. and let me know if you have any questions. But before we finish off, we need to have a look at the area of an annulus. An annulus is a circle within a circle, and you're only trying to find the area of the shaded section. Okay, so that shaded purple area there, that's what you want to find out. So it's basically finding the area of the whole circle, and you'll be given the radius of it. You're trying to find the area of the whole circle and take out the area of the inner white circle. Okay, so that's our area, or our formula to find the area of an annulus. Please copy that down. Again, the capital R is the radius for the big circle around the outside. The small r is the radius for the white circle in the middle. So please let me know if you have any questions. Hopefully you've copied down the formulas. Remember, you can always pause, rewind the video to make sure you have enough time to write everything down, and in case you missed anything. As always, let me know if you need any help. See you in class.